looking at this particular one, I am going to look for the one that has the variable easiest to get by itself. For these, I would say that this x is the easiest one to get completely by itself, right? Because it's almost there. And so I'm going to first get that by itself by moving the 8y over. So this equation can be written as x equals, the positive 8y will change to negative 8y minus 38. And so I have changed this linear equation by just manipulating it to have a variable by itself. I am now going to take the other equation, the one I haven't done anything with, and I am going to rewrite it. It is 13x plus 7y equals 88. Because I have solved for x, I'm going to take this and I am going to substitute it in for the x. All right, I'm going to substitute it in for the x. So I'm going to say 13, and instead of x, I will write negative 8y minus 38 plus 7y equals 88. And then I have a one variable equation that I want to solve for. All right, so I'm going to distribute here positive 13 and negative 8, or negative 104. 494, did I do that right? Yeah. Okay. 494. Okay, plus 7y equals 88. All right, combine your like terms. So my like terms here are the negative 104 and the positive 7, which would gives me negative 97y. My goodness. What were they? All right. Add my 494 over. I don't even like this. Here we go. So that's 500 plus, so 580. What did I do? 88 minus 6, 82? 582? Yeah, it is. All right. So divide and you get y equals negative 6. All that for a negative 6. Beautiful. Plug it back in. It doesn't matter which one, whichever one's easiest. So if I say x plus 8 times negative 6 equals negative 38. X, 8 and negative 6 is negative 48. Add it over, x equals 10. The next one is already solved. Y equals 1/2 x is already solved. So I don't have to get anything by itself. It's already done for me. I'm going to take this 1/2 x and I am going to substitute in for y because that's the variable that's by itself. So I'm going to say x plus 3, and instead of y, I am going to write 1/2 x equals 25. All right, so x plus 3 times 1/2, remember it's 3 over 1, so that is 3/2 x equals 25. These are like terms. There is a 1 in front of that. You need a common denominator. When you have a 1 and you're trying to get a common denominator with something else, it's just the denominator over the denominator. So this is 2/2 x plus 3/2 x equals 25. What's 2/2 plus 3/2? 5/2. Yeah, just add the numerators. All right, I need to divide by that fraction. What do I do when I divide by a fraction? I multiply by the... Not everybody at once. I'm dividing by a fraction. All I'm doing is multiplying both sides by the reciprocal. So I'm multiplying both sides by that reciprocal. Those cancel. And on this side, remember, it's 25 over 1, right? What can I do here when I'm multiplying these fractions? Cross cancel, right? This is 5, this, right? 5 divided by 5 is 1, 25 divided by 5 is 5. Now I have 5 times 2 over 1 times 1, which gives me x equals 10, right? No, so you do have to have 2 answers. Just plug it back in. If x is 10 and y is 1/2 of x, what is y? 5, there we go. So you should have gotten the answer 10, 5. You actually have 2 equations that have a variable by itself. So you can pick either equation and substitute it in for the other one. So if this is already by itself, this 3x plus 2 can already be replaced in this one for the y. So anytime you have the same variable already equal by itself, just set the groups equal to each other. By that I mean set 3x plus 2 equal to 5x minus 6. And then just solve. So I would move that 3x over. That would become a negative 3x, which would make that 2x. I would move the 6 over here to this side. The negative 6 become a positive 6. Cancel over there. 8. My last step would be to divide by 2. So x here equals 4. And then I can go to either equation to figure out what y is. Y equals, if I use this first guy, 3x. So 3 times 4 plus 2, or 12 plus 2, which is where I get my 414. All right, if I look at this, the easiest variable to get by itself is going to be this guy right here. Okay? That guy's the easiest. So what I'm going to do is I'm going to move the 4y over. So I'm going to rewrite this equation. X by itself would be negative 4y plus 30. And then I am going to take that x and plug it in to the other equation. So instead of 2x plus 5y, I'm going to say 2, and I'm going to replace my x with this negative 4y plus 30. Plus 5y equals 36. Distribution here, 2 times negative 4y, 2 times positive 30, plus 5y equals 36. Combine my like terms, the negative 8y, the positive 5y. And then I am going to move this 60 over, all right? So it's going to cancel here. It's going to be subtracting 60 here, negative 3y. 36 minus 60 is negative 24. Negative 24. My last step to solve for y is to divide by negative 3. Negative 24 divided by negative 3 is positive 8. All right, and then I can go back to either equation. My first equation here was x plus 4y equals 30. X plus 32 equals 30. Subtract over x equals negative 2, which is where you get this answer here. So looking at this is the one that's going to be easiest to get by itself. In order to do that, I am going to move the 8y over. So this equation is going to be 8x equals, because the 8y went across the equal sign, it becomes a negative 8y plus 36. And now I'm ready to substitute. So I have 3x plus 5y equals 13. That's the other equation. I got the x by itself, so that's what it's going to replace in this equation. All right, once I do that, I'm going to fill it in, 3. And instead of x, I'm going to write negative 8y plus 36 plus 5y equals 13. All right, I am going to distribute here. So 3 times negative 8y, 3 times 36 plus 5y equals 13. All right, combine your like terms. My like terms here are negative 24y and positive 5y. And then I need to move my 108 over. I'm gonna move that up. Negative 95. Divide both sides by negative 19. Y equals positive 5. All right, once I'm done with that, I just plug it back into either one. X plus 8 times positive 5, which is my y, equals 36. X plus 40 equals 36. Subtract it over, x equals negative 4. Solving by elimination. The elimination is also known as the addition method, because the process by which we are going to solve these is actually adding the two equations together. The goal of adding or subtracting the two equations is to eliminate one of the variables. Because if you can eliminate one of the variables, then you can solve for the other one and then plug it back in to solve for the first one. And so the first way that we're going to do it, you're going to see they easily eliminate, and then we're going to start having to multiply equations to eliminate. What you're looking for is that two of the variables will go away, or one of the variables rather will go away when you add them, when you add the two equations. All right? So let's look there right at example 1. Solve the system by elimination. Remember, this is also called addition. So you want them in the same order. You want them in standard form when you do this. Meaning you want your x, then your y, equal to your number. All right? When you look at these, you want to look and say, if I were to just add these straight down, would one of my variables eliminate? Meaning, would it turn to 0? Well, I have 4x and 8x. If I add those up, how many x's am I going to have? 12 x's, right? Look at my y's, negative 2y and positive 2y. If I add those, what's going to happen? 0, which means it's going to eliminate. This is what I am looking for when I am doing this method. I am looking for, will a variable eliminate? All right? If it will, you are ready to go straight to adding them up. All right? And so the process that you do is you add them up. So I am just going to take this, I am going to take these two, and I am going to add them straight down. 4x plus 8x we said was 12x. Negative 2y and positive 2y cancel to 0. I can just cancel those out because plus 0 doesn't change a number, right? So we can just cancel those out. Bring down your equal sign. All right. And then 13 plus 23, what is that? 36. I now have a rather simple equation to solve. How do I solve this equation? Yes, I'm going to divide both sides by 12. What does my x equal? 3. Am I done? What must I have to answer a systems of equations? An x and y. Have to have a coordinate, okay? You can go back to either one of them and plug that guy in. All right, so I can go back and say 4 times x minus 2 times y equals 13. 12 minus 2y equals 13, right? I can subtract that 12 over here. Negative 2y equals 1. And then divide by negative 2. Y equals negative 1/2. So my answer here is going to be 3, negative 1/2. So if you look at this, 3x plus 3x is going to give me 6x. 2y and 5y is going to give me 7y. Neither one of them will eliminate. And so one of the things it has in the book is this little question right here. Well, can I solve it by subtracting? If I subtract, will it work? All right? Subtraction is just adding the opposite. So there are two ways to look at this. You could multiply one of the equations all the way across by negative 1, or you could just subtract them, all right? Subtraction is just adding the opposite, so it's technically a form of addition. And you could just subtract them, all right? And so if they won't eliminate by adding, then you can say, well, will it eliminate if I subtract the two equations? And if that answer is yes, you can just move forward, all right? Because it's the same thing as adding a second equation multiplied by negative 1. So the answer here is yes. If I subtract, this will work. So I'm going to subtract all the way down. 3x minus 3x. That's going to give me my 0x. All right? You have to subtract all the way across, though. So I have 2y minus 5y gives me what? Negative 3y, okay? 2 minus 5 is going to give me negative 3y. And then 8 minus 14 is going to give me what? Negative 6. All right, I'm going to show you two ways to do this one. Divide by negative 3. Y is going to equal positive 2. Plug it back in, right? 3 times x plus 2 times 2 equals 8. All right, subtract my 4 over, and x equals 4/3 when you divide. All right, so my answer here is going to be 4/3 is my x, 2 is my y. All right, now if you want to, you can just multiply an entire equation by negative 1. All right, it's the same thing, and I'm going to show you that method too. So if I want to, I can subtract up, which is kind of a weird thing. It might be easiest just to change the sign of everything. Okay, so if you can see that it's going to cause a lot of positives, negatives, then you can just change the signs. So like this equation right here, I'm going to take this group and I'm going to do it again down here. All right. So subtracting, yeah, you have a lot of crazy subtracting going on. You can subtract up, that's fine. So you can say 3x minus 3x gives me the 0. 5 minus the 2 gives me 3y. 14 minus 8 gives me 6. Now you have to go the same direction. So if one's going to cause a negative and one's not, you can't go back and forth. That will cause a problem. The other thing you can think about is you can just multiply everything by negative 1, change the signs. So I can multiply everything up here by a negative and change all of these signs and then add. Okay, it's the same thing as which we're about to do actually in a minute is multiply. So if I did that method, negative 3 and positive 3 cancel. Negative 2 and positive 5. Negative 8 and positive 14. Okay, and so if the whole subtracting all the way down throws you off, just negate an entire equation. Whatever the signs are, change the signs. Because a lot of times the subtraction method works if it's all positives.
Sorry,
but if
I can't do that in that app.
See, even Siri can't do it. So it can throw you off if you're saying, oh, subtract here and then a negative minus a positive and then a negative minus a negative, and it just throws you off by doing negatives. Just negate an entire one, and it may be easier to just always add. So there's two methods. You can subtract or you can just always add and negate one entire equation. Methods here. You can subtract down or you can just negate an entire equation. If you see they are the same number, but they're both the same sign, okay? They're both the same sign, then you're going to have to change the sign of one of them. Changing the sign, you can multiply by negative or subtract. So like for this one, I could just multiply this entire guy by a negative and then always do my addition method. And that may be easier to just negate an entire equation and then always add, because adding sometimes makes it easier in our brains. Let's say they had given this to us. Subtraction sometimes throws you off because you have x minus x. That's the easy part. Then you have negative 2 minus 6, and some people are going to throw that off, especially if it's at the bottom and you're minusing a negative, and then all of a sudden you're like, wait, what am I doing? Okay, And so sometimes it's easier just to negate everything. So I'm going to change this to a negative, that to a positive, that to a negative, and then add. So sometimes just using that negation method keeps you from making an easy subtraction error between positives and negatives, okay? In this example, we're neither just negating an entire equation or adding is going to work, okay? So first I want to talk about why what we're about to do is okay mathematically. If I have x equals 3, and I multiply both sides by 2, I'm going to multiply this by 2 and this by 2, then I would get 2x equals 6. Is that the same thing as x equals 3? Yes, okay. So as long as you multiply every single thing on both sides of an equation by the same number, you do not change the equation. The equality remains the same, okay? So when I look at these two, I have a 2x and a 4x. That is not going to cancel whether I add or subtract. I have a 3y and a negative 9y, also not going to cancel if I add those two, okay? But they are multiples of each other, or they have a common multiple, okay? And so I am going to look at these and I'm going to say, could I multiply an entire equation by something and then add and get rid of something? Well, yes. I can multiply the top equation by negative 2. Why? Because my positive 2x would turn to negative 4x. And then I would have a negative 4x and a positive 4x. Boom, those would be gone, right? Now I would have to multiply the entire top equation by negative 2, but it will work. I can multiply the entire top equation by positive 3. Why? Because my y would become positive 9y, and on my bottom equation I have negative 9y, and I would be able to add and eliminate, okay? Does that make sense? And so I can look and say, is it possible for me to multiply one of these by a number and then cancel? And the answer is yes. And you can do it either way, and they will both work. One way you're going to solve for an x variable, one way you're going to solve for a y variable. Now, if I were doing this, I look for, again, the path of least resistance. I already have one variable that is positive and negative. Which variable is that? My y, no, my variables. My y, one of them is positive and one of them is negative already. Does that make sense? So I could multiply the y piece of it and cancel without having to worry about multiplying by negatives. So what I would do to get rid of this is I would multiply everything in this one by a positive 3 because I am trying to eliminate this y. Okay? All right, so I'm going to multiply every single thing in it. 3 times 2x, that is 6x. 3 times 3y, that is 9y. And 3 times 5. Most common mistake is not multiplying on the other side of the equation. That is 15. All right, so then I'm going to leave this one exactly the same. I'm not going to touch him. I'm just going to rewrite it, and you actually don't have to rewrite it, but don't, forget that you have to do all of it. Rewrite it exactly the way it is because I do not need to change it. Then I am ready to add, just like I did for the other ones. All right, just like I did for the other ones. All right, when I do this, I am going to get what I need to cancel. So I've multiplied everything by this 3, 6, 9, 15. I've left this alone, 4x, negative 9y, negative 10. Now I'm just going to add down. How many x's do I have when I add down? 10. I have 10x, right? What happens to my 9y's? They cancel. That equals 15 and negative 10. Give me a 5. What's my final step here? Divide by 10. So I have solved for my y. What do you think I want to do to that guy? Yes, I want to reduce it. All right. So go back to your original. I will say that the fraction is going to cancel in either one that you put it in. All right. So if I go back to the top equation, 2 times x, my x is 1/2, plus 3y equals 5. 2 times 1/2 is just 1, right? Subtract my 1 over. Divide by 3. And so my answer is going to be my x and then my y. 2 and 4, those were multiples, right? So 4 is a multiple of 2, 9 is a multiple of 3. So all I had to do was multiply one of my equations and I ended up with the same number. But for this, I don't. Like for this guy right here, I can't multiply 2 by something and get 3 unless I do a fraction, which I definitely don't want to do. So in this case, I have to multiply both of them. So I'm looking for a least common multiple between one of these. They happen to give us 2 and 3, so it doesn't matter which one. All right. So for this one, I'm going to say I need to multiply both. Which one do you think I'm going to cancel, the x or the y, just based on this?
The y.
And why do you say that? Yeah, I have a positive and a negative for my y. So I'm going to choose to cancel the y when I do this. So that means I just need to multiply the top equation. What is the least common multiple between 3 and 2? Least common multiple. That's going to be 6. So I need to get this 3y to be a 6. How do I do it? I multiply by 2. I need to get this 2y here to be a 6. How do I do that? Multiply by 3. So I'm going to multiply both equations. Distribute through 4x, 6y, and 12. 9x, negative 6y, and 24. And then I am ready to add down. Okay? Then I'm ready to add down.